Okay, so we have a question right here. It basically says that tennis players can practice using a tennis ball machine. The machine projects tennis balls horizontally from a height of 2.54 meter. Part A show that the time taken for a ball to reach the ground is about 0.7 seconds. Okay, so let's see what information we have been given. We have been given the tennis ball machine height from where the tennis ball will be projected, right? So it's Sy is equals to 2.54 meter. Now we have acceleration as well, which is the gravity, right, which is 9.81 meter per second square. We have also have initial velocity, which is 0 meter per second, as the ball is going to be at rest before it is being projected from the tennis ball machine, and then you have to find the time, right? So basically we can use the formula of S is equals to ut plus 1 by 2 at square, right? So your S is 2.54, your U is 0 times t, right, which is time. This will be becoming 0, right, plus 1 by 2. A is your acceleration, which is 9.81, and t is time, which you need to find. So basically it will be 2.54 is equals to 0.5. 1 by 2 is actually 0.5, so times 9.81, and which is t square, right? So we will shift it down here, so it will be 2.54 divided by 0.5 times 9.81, right? And then we can shift this square over here, which will become square root. So this is square root is equals to t. So your t value will be 0.716, sorry, 7196 blah blah blah. So if you round it off, it will become 0.72, basically 2 decimal place, or 2 significant figure, 2 decimal places, right? So basically this is your final answer. Okay, so part 2 says that the ball lands on the ground at a horizontal distance of 17.89 from the machine. Calculate the velocity of the ball as it is projected from the machine. Okay, so basically let's see what we have here. We have horizontal distance, right? Horizontal distance, which is 17.89. We need to find horizontal initial velocity, right? And we have horizontal acceleration, which is actually 0 meter per second square. This is meter. Why 0 meter per second square and not 9.81 meter per second square? Because the 9.81 was for only the vertical component, right? For only the vertical component we consider that it has the gravity acting on the ball. That's why we consider that the acceleration is gravity, which is 9.81. But for the horizontal part, basically there is actually no other force helping it to move more towards the right or more towards the left, or etc. So that's why as there is no force, there is no acceleration, which means there is constant velocity. Okay, so now we have time, which is basically 0.79 seconds. Yeah, sorry, not 79, 72 seconds. Okay, so basically from this information we can use the formula S is equals to ut plus 1 by 2 at square, right? So once you can see that the acceleration is 0 meter per second square, so we can cancel this out, right? And then we are left with S is equals to ut. So S is 17.89, U is basically we need to find, and T is 0.72. okay, so once you divide this 0.72 with 17.89, you will actually get 24.8, or if you round it off, it will be 25 meter per second. So your final answer is 25 meter per second. Okay, so part B says that the initial velocity of the ball as it is projected from the machine can be increased. explain how increasing the initial velocity would affect the angle at which the ball hits the ground. Okay, so let me explain it you through the vectors diagram, right? So this is the point where the ball is going to be launched, right? Let's first draw the ball with its normal velocity, not increased, right? So basically, let's say it will go till here and then it will basically land at this point somewhere, right? So basically this is your first line. We will use the head to tail rule to draw the vector diagram, right? This is your first line. Your second line starts from the head of the first line, and this is your resultant line, which starts from the tail of the first line till the head of the second line, right? So now this is your resultant, this is your velocity for the horizontal component, and this is your velocity for the vertical component, right? This is your right angle and this is your theta. Okay, so now we have, now from this point, now we have increased the velocity, right? So let's see what will happen, right? So if you increase the velocity, initial velocity, now the ball will go much more further than before, but it won't affect the vertical component for the velocity, right? Why? Because the only thing that is affecting it is basically the gravity, right, and nothing else. So the the vertical component will remain the same. So let's draw it this way, and the basically your resultant will be like this. Okay, so basically this is your angle, and if you compare the angle from before and after, you can see that the angle has decreased, right? So this is your right angle triangle, this is your horizontal component velocity, and this is your vertical component velocity, right? So now we just have to explain this diagram in word form, right? So let's write it out. Okay, so if the initial velocity is increased, then the horizontal component of velocity also is also increased, right? If the initial velocity is increased, then the horizontal component of the velocity is also increased. Okay, so now basically the second line will be you describing the vertical component, right? How the vertical component is not actually being affected, right? So the vertical component of the velocity as the ball hits the ground is not affected, Okay, so now you can either draw a vector diagram that I have drawn before in red color, or you can basically write this as well, like this was our vector diagram from before, right? And this was our angle, this was our right angle, and resultant horizontal component of velocity and vertical component of velocity, right? So now you can either use the formula to explain it, which is tan theta is equals to opposite over adjacent, right? Opposite is basically this, opposite to the angle, and basically this is your base, this is basically your adjacent, right? The base is your adjacent, so basically it will be tan theta is equals to opposite, which is vertical component of velocity, and horizontal component of velocity divided by horizontal component of velocity, right? Okay, so now you might be wondering like how this formula will explain that basically the angle is decreasing, right? So basically once you use the tan inverse, basically the tan going towards the right side, so it's theta is equals to tan inverse, it is also in your calculator, right? Your vertical component for your velocity and your horizontal component for your velocity, right? So as I told you that vertical component will not be changing, right? So your horizontal component will be changing, and how it will be increased. So if this is increased, then your basically theta will be decreased. You can test it out yourself as well. You can input these values in your calculator and check it out if whether it is it is increasing or decreasing. Make sure to use the mod degree, right? Mode should be basically degree and not radians, right? Some people have set their calculator in radians, so it might not show you the correct stuff, right? So make sure it's set to degree, and then you can test it out, and then you basically can write the same thing for the formula, and this will be your final answer for this 3-mark question, right?